try to sum up within the next 15 minutes the work and the activity of the IHRF Coordination Center, which we host in Thessaloniki, Greece, which is a new entity within the IGFS. And the scope of this service, let's say the entity, is to ensure the long-term sustainability of the IHRF, so the International Height, yes, this is the International Height Reference Frame. So, yep. So why do we need the IHRF and why do we go into this effort? Great, thank you so much. Yeah, thank you. So why do we need the IHRF and why do we go?
We don't see the slide.
Yeah, the screen, yes, sorry.
And why do we go into this effort? This is because, as you know very well, we have too many height systems around the world. These systems are not connected one to each other. And we really need a unified height reference system, height reference frame, in support of everything that has the prenom geo behind it. So in front of it. Great. Thank you, Martin. And we have been involved for many years in IHG in this field. So the basic idea is that we'll have a system which will have two potential differences, so potential values for stations around the Earth. It has a geometric component, so coordinates X, Y, and Z in the ITRF, and we'll have to estimate this guy here as potential differences with respect to a conventional W0 value that was decided in the IHG in Prague. So a little bit of history, how we arrived at the development and in making the IHRF Coordination Center a reality. This started within GGOS, actually, so it was a focus area led by Laura and Michael back in 2011. So a lot of work has been done for the definition of the system and then the realization of the frame. So as you all know very well, the frame is what is our effort to define values of heights, so of potential, in this system for stations around the globe. This work has been carried through various study groups, working groups within IHG up until 2023, where it was decided and was accepted by the IHG to establish the IHRS-CC. So this entity that will act within the IGFS as an umbrella of all activities related to the IHRF. So this is from a presentation that we had with Lauren in Thessaloniki about a month ago. This was during the Gravity Geodesy Height System Conference in Thessaloniki, which was a joint commission to IGFS and GGOS meeting. And you see here the distribution of the stations. These are around 170 stations around the Earth, which realize the IHRF. So these stations here they are the IHRF stations. These are collocated stations. So we have our gravity, measured gravity of these stations. They are very close to tight gauges, and we have GNSS data as well. This is, as I say in the last point here, a living network. So stations can come and go, and we are in an effort to make more stations available in the IHRF, especially in areas like here and here, where we do not have a lot of stations again. So for the IHRF coordinates, as I said, the geometric part will be coming from the ITRF. So in most cases, they are stations that participate in the regional frames like the URF or the ITRF itself. And for the heights, for the potential numbers or the potential values, what we are aiming at is at, let's say, an accuracy both for the static part and the time varying part, which will be in line to what we heard from here previously for the ITRF. In reality, what we are aiming at is just for the static part, for the time being, at reaching an accuracy at the centimeter level. So these are the numbers that we would like to go, and we would like maybe to go to the millimeter level and the 0.1 millimeter level per annum in the future, many years from now. But what we are at this point is the centimeter level. In the terms of reference of the IHRF, we have foreseen also the time evolution of the frame, but we focus ourselves for the time being only on the static part. Is this possible? Can we actually do it? Well, we're not sure yet. And this, I will elaborate on that on the next slide, because standard procedures like for the IHRF are not available yet. Why? Because the way you will compute the potential really has to do with the area that you are at. So you can follow very different methodologies and procedures when you are in an area which has a lot of gravity data, like in Europe or the States, and a totally different outlook when you are in a region that's not covered by gravity data. So this is why the determination of the potential values for the IHRF stations, it really depends on where you are. So you have some very, let's say, good scenarios where you have a lot of gravity data. So you follow the usual remove compute restore method to determine the potential of these stations. So you have a lot of gravity data, you combine them with high resolution potential model and topographic effects. You may have some surface gravity data of questionable quality, or no data at all. So in that case, what we rely ourselves on are the potential models and topographic data. And this has a result that we cannot standardize really the method, the approach that we should follow, depending on the area of the globe that we want to work on, and on the items that we actually get. So really, we cannot establish, let's say, a centralized computation center where we will carry the computations. And this also has to do with the fact that, as you know very well, surface gravity data are not available. So really, surface gravity data belong to some national stakeholders. So local people may have access to this gravity data, especially when we are talking about point values. So what we have established is, let's say, these entities that have to carry out all these activities here. So you have the coordination center that we host in Thessaloniki, Greece. We have an entity for the conventions of the system and the frame, the coordination of the network. We have the coordination that has the duty when we get many solutions for a station to do the combination of the solutions. And the most important part is associative analysis centers that we're elaborating them in a little while. So all of these work together in order to update the standards if we have to do the computation of the potential values and finally release these values. So why the associative analysis centers are very important? Because these are the local colleagues that have access to local gravity data, that know the situation in their country, who can actually do the computation of the potential itself based on this local gravity data. This is why we have established, for the time being, we have started at the beginning of this year, so in these first 9 months, a set of colleagues who are interested, who already work in this field, who will actually do the computation of the potential values based on the locally available gravity data for areas around the world. So this is, as I say, the real working power of the IHRF. And of course, we are carrying a lot of activities to try to attract more people to work for the IHRF in their own country by presenting and promoting the IHRF at various conferences. What we have done for the dissemination, we have set up the website, we have an aliasing, an email alias where we can communicate, and we have created a repository of some very fundamental documents. So some basic bibliography about how you can do, about what the standards are and how you can do the computation of the potential values, and also a short version, like a cookbook, that people who are interested can actually follow to do the computation of the potential values. So this has been presented in Thessaloniki just a month ago. This is the first realization of the IHRF, during which we have computed potential values based on the global potential model and topographic effects for the stations that you have seen in the previous month. So either as height anomalies or orbital heights. For the time being, we have not uploaded these values yet to the IHRF site. This will be done until the end of this year, where we will also have the metadata. So for a station, people will be able to see how the computation has been done and also the availability of the values. As you can understand, based on the fact that we cannot have a single strategy to do the computation of the potential itself, it's really hard to do the evaluation of the results. The way we have two approaches, let's say. The way we will actually do it is to have some simulated data, so based on the potential model and topographic effects, and also some real data based on the Colorado Geodesy experiment, where if we want to test a methodology for two different methods, then we will first do the computation using this simulated data and the real data from the Colorado experiment, get the results and compare them. Moreover, when we are having values for neighboring countries, then we will use available geoid models from the International Service for the geoid in order to evaluate the results. Two examples, you will see some good and bad cases and scenarios. Here is this cross-examination, the cross-validation based on Canadian and US colleagues. You will see that for the stations, they did the evaluation of the potential values for the IHRF sites. And you see that the results that are achieved are fairly good. So we have a mean difference of at the centimeter level instead of deviation at the 3 centimeters level. So these are using two different geoid models. But you have, of course, some stations that deviate a lot. So you have maximum and minimum differences at the 5 and 10 centimeters level, which are fairly good. Another example here in South America, using two different geoid models. You see, okay, here the topography is quite rough in the Andes here. And you see that for the stations on the lowlands, the differences are very minimal between the two approaches. So we have statistics here for all points, these 20 points, and 18 points by excluding these huge differences here. This is the mean differences at the millimeter level, and again, we have standard deviations at the 12 centimeter level. This means that despite the fact that we are following more or less the same approaches, so employing local gravity data and the same methods, the estimation of the potential value is still not a trivial process. And this has to do with the topography and the way we handle these effects. It's a global effort, as I already mentioned. As I would say it again, the real working force of the combination center and the coordination center are our colleagues working around the world. So, and you see that the results that we get until now are mixed based on the availability of gravity data. You have some very good, let's say, areas like US, Canada, Europe, and so on and so forth. And you have some areas like, for example, in Africa, where still the achievable accuracy, due to the fact that we do not have gravity data available, is not as good. But it is an ongoing effort. What we have achieved thus far is, let's say, this cookbook that I already mentioned, that really for people who are interested, especially from developing countries, I will go to the previous overhead. We really need more stations here in Africa, in the Arabian countries here, over Iran, and here in this part of Asia. This gives our colleagues from especially developing countries a roadmap of simple steps that they can follow to contribute to the IHRF. We are aiming at developing something similar to what happened in GGOS. So one or 2 pages, 1 page, a white paper saying what are the benefits and the pitfalls of having the geoid first and then potential values for your stations. This is really important, especially for our colleagues from developing countries, when they want to convince the stakeholders to fund, for example, acquiring gravity data or establishing these stations. And the first realization has been presented in Thessaloniki, as I said, a month ago, and hopefully it will be online on the web with metadata available by the end of this year. Last but not least, these are all the people working in the IHRF, and I would really like to acknowledge their work on it. Thank you very much.